What's happening, everyone? Today's lesson is going to be a quick recap on sequences, and then I'm going to ask you to go and complete a Hegarty maths task that I'm going to kind of talk through with you there on the next page. Okay, so very similar to the other ones that we've done like this. This time it's on sequences. You've got your sequence in the middle there. So what I'd like you to do, pause the video, have a go at these 4 questions, please, and then we'll come back and go through them together. Right, so 3, 7, 11, 15. Okay, let's just go round in clockwork order like that. Write the next 3 terms of the sequence. Hopefully you can all spot, like, it should be quite easy, that one. 3 up to 7 is adding 4. 7 up to 11 is adding 4. 11 to 15 is adding 4. So clearly the rule here is adding 4, isn't it? So what would come next after 15? Well, that would be 19. What will come next after 19? 23. What will come next after 23? 27. Okay, this one, write the term to term rule for the sequence. The term to term rule is just how do we get from one term to the next term. So how do we get from 3 to 7? How do we get from 7 to 11? How do we get from 11 to 15? So on and so forth. Well, that this time was just add 4. We've already spoken about that, haven't we? Okay, right, write down the nth term for the sequence. Now remember, your nth term means it's going to be something like 7n minus 2, or 12n take away 8, or 10n plus 4, or something like that. And every single linear sequence is based around a times table. So this sequence is just a times table, but then shifted, because if you think about it, your times tables always go up by the same amount each time, don't they? So this one, we have a look at what it goes up by. And whatever it goes up by, that is the times table that it's based on. So this one, I'm going to write out 3, 7, 11, and 15 here. Because it's going up by 4, it is based on the 4 times table. And the 4 times table can be expressed as 4n. So that's 4, 8, 12, and 16. So the sequence 4n would be 4, 8, 12, 16. Now, how do we get from 4n to our numbers each time? What do we do? Hopefully you can spot there, taking away 1 each time, aren't you? So my answer to this is 4n minus 1. Okay, so look for what times table it is, and then think about how you would get from just do the first number. Say, how will that? Okay, if it's a 4 times table, it starts at 4, but this time I'm starting at 3. So that means I need to take away 1, so it's 4n minus 1. Right, and the last one, John says that 81 is a term of the sequence. Is John correct? Explain your answer. Now there are 2 ways to do this. One would be to just continue up the sequence. Okay, now sometimes you can spot that it's not in a sequence because especially if you're adding on 10 each time. Let's say we were doing 2, then 12, then 22, then 32. Would 81 be in that sequence? Well, no, it wouldn't, would it? Because it's going to hit 82, not 81. So it's going to jump over 81. So sometimes you can just spot it. However, with this one you can't, because that ends in a 1, doesn't it, there? So it might be in the sequence. We're going to have a look at it. So there's 2 ways of doing it. You can either continue the sequence right the way on to see if we hit 81, or we can use the nth term. Because remember, what this means is that when n is 1, we'll get the first term. When n is 2, we'll get the second term. When n is 3, we'll get the third term. So n would always have to be an integer. So what we do is we set up an equation effectively asking, will 4n minus 1 ever equal 81? And when we solve this, if we get an answer that is a whole number, then the answer is yes, it's in the sequence. And whatever number that is, say if it's 50, it means yes, 81 is the 50th term in the sequence. But if we were to get an answer, say like 50.2, it means that it wouldn't be in the answer because it would be between the 50th and the 51st term. So let's solve this. Okay, dash line down the middle, add 1 to both sides, so we get the 4n equals 82. Divide both sides by 4. 82 divided by 4 is 20.5. So no, it's not in the sequence. It's between the 20th and the 21st terms. Bang in the middle, actually, because of that 0.5 of the 20th and the 21st terms. Okay. So those are the things that you'll need to be able to do for sequences. Okay. Now on the next page, what I'm going to do is go through each type of question on the Hegarty Maths task that I've asked you to do. So your Hegarty Maths task is 5 questions long. They will all look like this. So it's up to you. If you're confident with this and you want to just go and do it on your own, you can do. But basically what you could do here is if you open up the Hegarty Maths task, I'll talk you through this one. You can just pause it and then do your question 1. Then I'll talk you through question 2. You can pause that and do question 2. Okay. So what is the nth term rule for the linear sequence below? So what's this going up in this time? What's going up in 3's, isn't it? So that is going to be linked to 3n, which would look like 3, 6, 9, 12. And we need to think about getting from 3 to 5, from 6 to 8, from 9 to 11. Okay. What's happening each time? We're adding 2, aren't we? So that one is 3n, add 2. Okay. So if you want to pause the video, have a go at yours. Otherwise, we'll just carry on. Nth term for this one. What's it going up in this time? Minus 5 to 2. That is adding 3 as well. Minus 2 up to 1. That is adding 3 as well. 1 up to 4, adding 3. So it means it's based on 3n again. Okay. So what's happening this time? Now we're going from 3 all the way down to minus 5. That's take away 8, isn't it? So this one is 3n minus 8. By the way, the reason that I kind of stopped was I was going to explain that when you've got like minus 5, minus 2, 1, 4, 7, if you can't spot that that's plus 3 there, just have a look here. 1, 4, 7, that's definitely adding 3 in it. And then just kind of go back and make sure you take into account that that is the first term. So you're finding that tricky to spot. Like there, if I can't spot that I'd need to take 8 away from 3 to get down to minus 5, then look at that column there. I'm going from 9 down to 1, which is definitely take away 8, isn't it? Okay, so that was my answer for the second one. So I'm going to pause yours and have a go. Right, and then question 3, we're going from 15 to 7. That's take away 8, isn't it? Then from 7 down to minus 1, take away 8 again. From minus 1 to minus 9, take away 8. So this is based on the minus 8 times table. Okay, the minus 8 times table, which is basically the 8 times table just with a negative in front of each number. So what do we do to get from minus 8 to 15? Well, that's going to be adding, isn't it? How would I get from minus 8 up to 15? Well, I'd need to add 8 to get to 0, and then I'd need to add 15 to get from 0 to 15. So 8 at 15 is 23. So this is going to be minus 8n plus 23. Okay. So that one, it's tricky that because it's negatives and everything like that, isn't it? I get that. If you wanted to there, by the way, to get that number there, you could do 15 minus minus 8. If you've got a calculator there, that'll do that for you. 15 minus minus 8 gives us the 23. It's positive 23, so that's where that comes from. You can write that as well if you wanted to as 23 minus 8n. Okay. Right, question 4. What is the 30th term of the linear sequence below? Now, again, hopefully you've spotted there, that's that sequence, isn't it? So if you get one that you've already done, just check back through. If you've got one that you've already done, just use that answer and then do what we're going to do in a second. If not, figure out the nth term for that and then do what we're going to do now. So we know that the nth term for this one is 3n minus 8. Now what that allows me to do is to say, well, if I want the 30th term, I just do 3 times 30, take away 8. Okay? Which is 90, take away 8, which is 81. Okay, dead easy. That's why the nth term is dead useful. And then the final one, I don't know if you can see mine, if you just zoom in a little bit on that, is minus 204 in the sequence below. So let's have a little look what's happening here. This is taking away 4 each time, isn't it? Okay, so it's an even number, so it might be in the sequence. So let's do what we did here. Okay, it's figured out, what we did on the previous page. It's figured out the nth term. So it's going to be minus 4n, which would look like minus 4 minus 8. How do we get from minus 4n up to 22? Well, let's do what we did before with that. It's going to be 22 minus minus 4 plus 26. So we've got minus 4n plus 26. That's our nth term for this sequence. So how do we figure out then if this is in it? Well, we set it equal to minus 204 and then solve that equation. So I'm going to take away 26 from both sides. So I've got minus 4n equals, calculate it, minus 204, minus 26 will give me minus 230. And then I'm going to divide both sides by minus 4. And remember, if my answer here is a whole number, then it is in the sequence. If it's not a whole number, then it isn't in the sequence. So there I'm getting 57.5. So no, it's not in the sequence. Okay. So can you go and have a go, please, at clip number 198 on sequences that I've set you on Hegarty Maths. Use these, go back over these and have a little look at what I'm talking about there to help you with that. And any issues, let me know, please. Good luck.